This video goes over what a Z score or standard score is in terms of a normal distribution. So the first thing that we need to remember is standard deviation, which is the average distance any given x value is away from the mean. Any value x in a normal distribution can be expressed as x equals x bar plus z times sigma. Z is the number of standard deviations either above or below the mean. X bar is our mean, and sigma is our standard deviation, just like before. So for example, if you're investigating the heights of university females in centimeters, you know that your mean is 165 centimeters and your sigma is 15. If you have someone that is 150 centimeters tall, that is someone that is 1 standard deviation below the mean. If you have someone that is 195 centimeters tall, that is someone that is 2 standard deviations above the mean. So if we solve for z based on this equation, the first thing we do is move x bar over to the left-hand side, and then we're going to divide both sides by sigma. And this relationship gives us the z score, which tells us the number of standard deviations a value is away from the mean. A positive z score tells us that our value x lies above the mean, and a negative z score tells us that our value lies below the mean. So for example, if we have a distribution that looks vaguely normalish like this is where our mean is. Over here, this area, this represents the data that is 1.75 standard deviations below the mean or to the left. So our first example here, a population has a mean of 18 and a standard deviation of 3. Find the standard score or the Z score for 22.2. So we know that our Z score is equal to x minus x bar over sigma, and then we can plug in our values to solve for our standard score. So our x is the 22.2 that we're given, x bar is 18, and then sigma is 3. Dividing all those out gives us 1.4. So that means that 22.2 is 1.4 standard deviations above the mean. The second example that we're going to do is where we're given the mean of a population. So we know our x bar, our standard deviation is 12, and we want to find the value that has a standard score of minus 2.8. So this time we know our Z score and we're looking for our x value. So again, setting up our equation for the Z score, and then we're going to substitute in what we know. So minus 2.8 equals x, we don't know that. 42 is the mean, and 12 is our standard deviation. Multiplying both sides by 12, and then adding 42 gives us an x value of 8.4. So that tells us that 8.4 is the value that has a standard score of minus 2.8, or the value that is minus 2.8 standard deviations below the mean. The last example that we're going to do here is about IQ scores. And so here we have the IQ scores for a particular test are normally distributed with a mean score of 100 and a standard deviation of 16. What is the percentile rank of a student with a score of 134? So the first thing that we need to do is figure out the Z score. So Z is 134 minus 100 over 16. So if we go backwards one step, this is our x minus x bar over 16 over sigma. And then when we figure that out, we get z is equal to 2.13. Now that we have the z-score of 2.13, we're going to use our z-score table to figure out what percentage that represents. So we've got 2.13, so we need to scroll over. So the middle here gives us our positive z values. We're going to go down to 2.1, and then we go over in columns until we get to 2.3, and we find out that using our z-score, we get, how do I want to write this? Using our z table, we find that that represents 0.98341, or about the 98th percentile. Using that z-score table tells us how much area under the graph that covers up to that 2.13. So if I were to draw here like this, I know I've got a z-score of 2.13, so I'm quite far above the mean at 2.13. This represents the amount of area that is underneath the curve. And this tells me that the student is in about the 98th percentile. Those are some examples of how you calculate the z-score and how you can use it to determine statistics.